Remember where we were when we were together last? We were basically, we're working on conversions, right? I'm trying to teach you a method by which you can make conversions. Okay? Sometimes people call it the factor label method. Within it, though, you're going to have a couple things in place. One is it's helpful to use scientific notation. That's a kind of a side note. A way to represent large or small numbers very quickly, right? You also need to know how to use metric and metric prefixes. And that's part of the conversion part, is sometimes how to just convert within a metric system. You know, you have something in millimeters, you need to turn it to centimeters. How do you do that, right? So one of the things I would point out when you're doing this conversion part, and I think we're just about through enough of this. Okay, so first off, I'll stop here for just a second to make sure everybody's kind of focusing on. Of the metric conversions, you only need about 4. Okay? Is everybody okay with that? So I got to go from very small, from micro something. So I'll just use meter, but it could be meter, it doesn't matter, you understand? So micrometers to meters, millimeters, millimeters, centimeters to meters, and then the big one, kilometers to meters. Is everybody all right with that? So those are the 4 standard conversions. And then there's this other thing that's very unique, and that is a derived volume unit. Okay? When you say it's a liter, that's derived from a meter by a meter by a meter. Does that make sense? So it's derived from fundamental, how much volume is in here? Well, if I could measure the diameter, whatever. But if I made it like a square, it's easier to think about. Width, length, right, and height could do the volume. But that would be in cubic centimeters. But yeah, we don't describe it cubic centimeters. We use the derived unit, like a liter. So the link between the standard units, which have the cubes in them, or even areas the same way, the squared units, to the derived units, like the liter. Anybody know that bridge? It's just like there's a tunnel that gets you from one to the other, back and forth. If I had 40 milliliters and I had to turn it to cubic centimeters, I'd have to go through what little caves?
1 milliliter is equal to 1 cubic centimeter.
Yes. You made it very simple, but that's exactly it. But everybody has to know that fact. So if I'm sitting there looking at a cubic unit and I know on the other side I've got a derived unit like a liter, there's only one way across that pass. I'm talking Colorado language, right? That, you got to go through one mountain pass and one alone. And that's 1 cubic centimeter equals 1 milliliter. That's your linker. Okay? So we worked on that. So now, as we were together, we kind of had some other stuff we reviewed. Remember that you can flip them, it doesn't matter. 1 gram, we're saying there's 100 centigrams in a gram. There's also a gram and 100 centigrams. You can say it either way. It's still true, right? Flip that. That'll make sense when we're doing the math. Okay, so now what I started to help you try and think about how you do conversions is it a one-step conversion or is it multi-step? You with me? You can do that from the beginning by the question. And the minute you see this, there's a prefix. Noah? There is no prefix. That's a one-step conversion. So if there's no prefix, you're going to a prefix, right? You're saying, oh, it's one step. If you see 2 prefixes, how many centimeters are in 50 millimeters? Oh, that's a 2-step conversion. And that's as I teach it to you in the beginnings. Later on, people get used to moving the decimal just so many times. You get shortcuts. We're not going to start there. We're going to just start with a very foundational, here's how you do it. Does that make sense? Here's your other clue that you're about to do multi-step conversions when there's powers involved. So if it's squared or it's cubic, right? You're going to have to do the conversion. Does anybody remember what we talked about when we talked about doing that? So I can jump up there and kind of get you through there. So, how many steps just by looking at kilograms and centigrams? Yeah, there's at least 2, at least, right? Good. How many cubic feet are in 895 cubic meters? How many steps? I mean, you don't have to know the exact, but is it 1 or more? More, because you see the cubic power. And in fact, how many times do you have to use the factor? 3. In fact, if you look at the power, it tells you how many times you got to use the conversion factor. You know? And so I'm remodeling my house. I'm always weighing over my head. I've got 40 things going at once, right? So, you know, I go to order painting. I'm going to measure square feet. And so I got to do a calculation. Well, I'm not going to measure square feet. I don't have a square foot measure. What do I measure? I measure height and width and calculate square feet. So if I do a calculation, oh, it's 10 feet by 12 feet, that's 120 square feet. Then if I have to do any kind of calculations, any conversion, I got to make sure I do that conversion twice because it's square feet, right? So that's the secret sauce. And you know, here's a great example. How many times am I going to do the conversion factor? 3. And sure enough, when I set it up, I do it 3 times. That way the units cancel. And then people were catching this towards the end. I think they realized, oh yeah, look, if this conversion factor is on the top, mathematically, what am I doing with these numbers? And if the conversion factor is on the bottom, dividing. And it's okay to just divide, multiply, multiply, multiply. It's all good. And then somebody else brought up, yeah, but what about the caret key to do it all in one swing? Yeah, that's all good. No, you know, it's all good. Nothing different there. And that's kind of what this was all about. You can either do it this way, you can do it this way, or you can do it. This is where we were at. Everybody tracking with me? So again, I kind of reinforce everything I talked about. And then here's the bridge. Any of these are derived units. They're liters, right? Any of these are cubic units. They're fundamental. The only way to get from here to here is through 1 cubic centimeter per 1 mil. That's the key. So in your head, you should be, get used to that. All right, so you're now here. Like if you could do this, we can do some of these. Shall we jump in and do this together? Make sure everybody's setting this up okay? Is that all right? This is good. This is a good plan. So I got 1, 2, 3, 4, 5, 6. Man, is that ever perfect? Because basically every row is going to get one problem. So you guys are now a team. You guys are a little shorter team, and these guys are just a few more people on them. That's okay. So now we have, we're going to just work our way from the bottom up, and we'll work this way. You got the bottom problem. You got the next one. You guys back there. You got the next one. Make sense? You guys have this one. There we go. Here we go. Make sense? And there's nothing meant by I'm working my way to the top, whatever. You guys are number 2. Thanks. Good stuff. And what I would like for you to do is I would literally like for you to come up to the board. So, once you talked it out, you talk to each other and you go, hey, I'm doing the exact same, I'm getting the same answer. This is how I want to do it. Then somebody come up and present it. And you guys, when you present it, don't just write down the answer. Will you please start with what you're starting with? What units you finish? Set up the conversion factors, show how they cancel. So we can see that you're doing that technique together. And so I'll put plenty of markers. You got lots of workspace up here. I'm just I'll stop recording so that you guys are on. We're chatting. You don't want to, later watch YouTube and hear you guys would try to get the conversation and just seem picked up. But here we go. So there's that. I might just spin it around and see it just so everybody can see that work later. There we go. There we go. Hopefully I'm somewhat close to what I'm looking at. There we go. All right. So on we go. See, hopefully I'm where I think I am on that. Slides. And the reason I'm highlighting this, well, with my PowerPoint slides is just reinforcing again. If you're paying attention to the prefixes, then you see there's a multi-step conversion coming, right? I pay attention to the prefix, I know there's a multi-step coming. I pay attention to this and I go, how many steps? Just one. And then when I see these, I go, oh, right? I keep pointing to you because you pointed out that tunnel, right? Oh, here comes the tunnel. Because these are, right, these are derived volume units. You got to get a sense of what that means the minute I see cubic centimeters. I'm talking about how much space it occupies. It's a centimeter by centimeter by centimeter, right? That's volume. If I hear area now, something squared, I'm thinking like, oh, length and width. It's like, how much paint to do that? How much carpet to do the floor? That's going to be in square centimeters, right? Or square meters, right? Okay. There we go. And we are off. That, I think I got it all set up for you so you can practice that later if you want to look at it. Same thing that you guys did. Now, here I'm using the scientific notation. 1 times 10 to the third is the same thing as 10 to the third. And so some tricks, if you watch the, I did this, chemistry boot camp with Dr. T, and it'll show you some little sweet little scientific notation tricks. I don't spend tons of time with you guys because we have too much going on this semester. We don't have time to get down into that. But if you want to learn how to use scientific notation quickly, it gets pretty easy. Because basically what happens when I multiply things, they all add. So this is 10 to the 9th, but it's on the bottom, so it's times 10 to the minus 9th, and I immediately know it's 895 times 10 to the minus 9th. No, I'm done. So those are, you can just almost do those in your head. So enough of that. Okay. So we'll take a minute with temperature. I want to say right from the preface that I will always give you the temperature conversion formulas that you need. All right? But you do need to be able to convert temperature. Right? And for you working, you can obviously Google it. It's going to be super simple. But first off, it's not like all of these. After working through all that, and then we bring up temperature, the thing I can't tell you is you can't use dimensional analysis to do temperature analysis. Temperature is very weak. So you have to know these awkward formulas because, back to the math of it, it mixes multiplication, division with addition, subtraction. So then you have to do order of operations, and it changes everything. Because everything we just did all involve multiplication, division. If you get real nerdy on that, that's a commutative property. It doesn't matter what order I do it in. It's really helpful. Okay, so we got kind of what the English, and then I heard the term imperial the other day, and it's like, which I don't really love the term, right? If everybody knows the root of the word, it's very awful term. Okay, it's based on human body temperature being 100 degrees. We're going to talk about temperature Fahrenheit. So in theory, they roughed out human body temperature way, way, way early and called it about 100. And then a salt solution, which freezes a little colder than regular water, is called 0. And that's the scale. Okay? So Fahrenheit is based on human body temperature being about 100. We now know, as we've kind of done it and averaged and whatever, it's about 98.6 degrees Fahrenheit. Okay? Metric is a lot more practical. It's based on pure water freezing and boiling So boiling point of water is 100 degrees C. The freezing point of pure water is 0 degrees C. That's standard conditions, standard pressure. That's really easy. But Kelvin is based on pure molecular motion. So it is actually the truest measurement that will be used for calculating physical quantities. We'll get to that later. We do a little bit of gas work. And so the model is just this. Temperature is movement. Right? So if I could see the atoms, like, okay, this is a solid substance at room temperature. I can see those atoms. They're still moving. And if I froze this thing to 0, they wouldn't stop moving. They'd still be moving. In fact, if I started cooling it, they'd slow down, slow down, slow down. In theory, they would stop moving if you hit 0 Kelvin. So Kelvin is the true measure of molecular motion. Now that's a construct because it's a theoretical point, because one of the laws of thermodynamics says you can't hit absolute 0 because molecular motion stops and everything just kind of crashes in on itself. Sounds like an Oppenheimer scene from the movie, right? Well, that's where those guys live. They grew up that way. Okay? But it you kind of generically understand the idea. It's very related to motion. So it's the proper measurement. So to put it in perspective, when water freezes and it's 0 and it feels like North Dakota cold out there, you still have 278 degrees of motion that are left. So you're well far away from being actually 0. And so the things that we use are like liquid helium runs about 4 Kelvin. That's cool. I've actually done experiments that we pulled vacuum on and did all sorts of stuff, got it down to 2 Kelvin. That was crazy. It was a party. Because the samples, when you got them that cold, when they started to heat up, you had to figure out a way they wouldn't crack and explode. So we ran this instrument, and it was like a nerd holiday. Hey, we're running EPR at 2 degrees K. Anybody who needs samples, you got to come to campus and do it today. And we had tubes that we were trying to carefully get back up to temperature. They weren't exploding. Sometimes they come out of the instrument because they just expand. The gases expand, and I had tubes shot up into these kind of ceilings where they're stuck, and it was just like, it was crazy, but it was wild to work with 2 Kelvin. Here's your conversions. So we'll take a minute, we'll write them down, and then they'll be given back to you anytime you have a quiz test. I'll point out a few things about them, and then we'll just start using them. And that'll be it for converting. Then we'll kind of do a little bit more math stuff and hopefully talk about chemistry today. I know. I really like chemistry.
Oh, yeah.
Yep. Yeah. Okay, so somebody's asking me about 273.15 to be more exact. And I'm going to just stick with 273 because that's going to be just easier for all the work we do. So that's important because if you do homework and you're doing a conversion and you add 273, you'll get the answer correct with the software. If you added 273.15, you're probably still going to get the answer right. I got a little bit of play over, but I'm just trying to save you guys some steps. Now, first off, make sure you understand, remember order of operations in math, right? You add and subtract, that's the lowest priority. Above that's multiplication and division. You got to do that first. And above that, there's powers and roots. And above that, there's parentheses. So with all that in mind, when I look at this, the very first thing, when it's written as is, I have to multiply before I add. Okay? When I look at this, I can't multiply by this fraction. I have to subtract because it's in the block. Now, if you have a scientific calculator and you lay it out like this and use the parentheses, it will absolutely always be right. If you have a non-scientific calculator, it still would be right. Still would be right. So probably okay. Are we ready? Any questions on this as you look?
Yeah. A question on the last one.
Yes.
Why is it equals Fahrenheit?
Probably because it's wrong.
Yes.
Yeah, thank you. Thank you. Thank you. Jump to those quicker so we can get those corrected. You guys all are right. Now I have to correct. Yeah.
Well, we need to know the thing to go from Kelvin to Fahrenheit because it's like.
Yeah, so Kelvin to Fahrenheit's 2 steps. It's a 2-step conversion. We'll work on that today.
Okay.
So there we go. There you go. I got a little swag for you. It's actually a NASA tattoo. Ooh, yeah, there we go. What?
No, next time I'm wearing this.
Yeah, right. There we go. So here we go. We're going to practice. And I'll just kind of walk you through. I think most of you are going to be pretty straightforward on this, but this is the easiest way to do this, is actually just build a grid like this, and then you can just fill in all the blanks, right? But if I'm at 50 Fahrenheit, right, and I'm trying to go to Celsius, the first thing I do is, right, we got to get a formula together. So you guys tell me, if I'm at Fahrenheit, what do I do first?
5 divided by 9, then open brackets.
And then open brackets.
Fahrenheit minus 32.
There we go. That's where we're going to start, is Fahrenheit minus 32, right? And that's actually like this, correct?
Yeah.
And then we're going to go, Fahrenheit's going to get a little smaller, so I make a small fraction. It's going to look like this, correct?
Mm-hmm.
It's pretty straightforward. It's 50 minus 32, 22.
No, like 18. 18.
I'm just rolling with what you're saying. 18 times 5 divided by 9. Oh, this is kind of cool. Because, you know, I told you the division can go first, right? Doesn't matter the order. What's 18 divided by 9? 2 times 5 is 10. There we go. But if you have a calculator, 18 times 5 divided by 9, that's all fine. So we got that. And then if I have 10, I'm going to Kelvin, I'm going to go 10 plus 273 equals 283, and then I'm filled in there. Good. Now, if I'm at Celsius, I can go either way, right? I could go over to Kelvin, I can go back to Fahrenheit, doesn't matter. Which way do you want to go?
Fahrenheit.
Fahrenheit. Okay, we're going to Fahrenheit first. So now I'm at minus 15. So now what I'm going to do here is I'm going to say if I'm at Celsius, I'm going to go 9/5, and then I'm going to add 32. So minus 15 times 9 divided by 5 plus 32. So again, this is kind of handy because 15 divided by 5 is 3 times 9 is 27. So I'm at minus 27 plus 32. Somewhere around the neighborhood of 5 degrees. And I don't know if that's the way it went. But the other way I could have gone was I could have gone minus 15. So we know if I was at Celsius, right, I would get, what would I do to get to Kelvin?
From Celsius plus 273.
There we go. So I'm going to plug in minus 15 plus 273 equals
258.
258?
Yeah.
So yeah, that's a good example. It's minus 15 degrees C. That's pretty dang cold, right? I mean, it's 5 degrees out there, but yet it's plenty of temperature. And this is what your comment was. You know, if you start here and you got to go all the way to here, it's a 2-step conversion. You go from here to here, then here to here, always. Vice versa. So, Kelvin minus 273 ought to equal Celsius, not Fahrenheit, Dr. T, right? So 155. Oops, what am I doing wrong? Who knows? Oh yeah, that's right. Minus 273. Minus 118. And usually people put a degree C and a degree F, and Kelvin has no degrees on it. I don't know why.
Maybe because there are other things that measure DC and F.
I'm not quite sure. What do you'd have to explain that.
Physics, maybe F without a bubble, without a break means something else.
Oh. It's like a concept for something else. That's an interesting thought. Trying to think in my little brain if I know what that would be. It's a thought. No, it's a good thought. Yeah, I get you. So Celsius, right? And we're going to go so if I start off with minus 118 and just figure that out. And by the way, when you're using this on your calculator, the one thing I always encourage students, make sure you know that there's a negative sign and a subtraction. For some reason, the calculator won't do that the same. And notice that doesn't make any sense. Mathematically, the exact same thing. So anyway, just so you know, when I'm trying to plug this in, I need a negative number. There's actually a negative sign. It's usually blocked off like this, which is different than the subtraction sign. Okay? So, everybody feel good about that? No, not really.
I got lost.
On which part? Just ask me to do one of them in particular.
So I got lost where you subtracted 15
Yes?
to get 5.
To
Like,
where
so
from here to here?
yes.
Okay, here we go. We'll just do that. Okay, I'm at minus 15. Okay, I'll take it a little slower. Apologize. So I'm at Celsius. Here's the formula. I'm just going to put the formula down first. Is that okay? And I know that's what I have. That goes there, correct? So minus 15 times 9 divided by 5 plus 32. All right. So here's what I'm going to do at this point. I'll give you a second. Give me a thumbs up when you're in. Good? Okay. So what I want to do is on my calculator, I want to enter this. It'll look like this. I'll hit that negative sign. I'll hit 15 or I'll go 15 negative. I don't know which one order yours goes in. Maybe, is it 15 then the negative?
Yeah.
Okay, cool. So you now have that. Then you go, this is on top. So I go times 9 divided by 5. And then I can either say equals or I can say equals plus 32 equals, or I can just say plus 32 equals all at once. Because it will know how to do that. And then see if what comes on the screen is what you're looking for, the 5. Work out?
Yes.
Perfect. That helped? Thanks for slowing me down. Yes?
So you always have it set up where it's like a series of conversions, or you have a single.
Oh, it'll be a one single type question. But this exercise allows you to walk them all through. So this is the way I would practice so that you get very good at going through any of them. And because I chose, right, when I set my original problem, if I know I'm at Fahrenheit, I'll have to do the others. And then here I'll have to do this, and here I have to do this. So that's how I know I covered all the bases. I've done everyone that I could possibly be given.
So for the bottom row, I converted Kelvin to Celsius then to Fahrenheit. But negative 1.4. Do you want us to always just like round up on the answer?
Yeah, and the nice thing is, are you guys hearing the question?
Mm-hmm.
Exactly 180.4, for example. What are you going to do? Here's the glorious part. If you started doing the homework, which you can just dive in tonight because it'll have a lot of this. I usually on the homework have tweaked them to say, answer to the tenths. And after today, I will show you how to know exactly how many answers you should really put in there. Is that good? So it's really nice because I'm going to say, quite often I'll say, answer to the hundreds. Like I'll say, answer to the hundreds, and then I'll have this little hint to say, oh, answer all the way up. Is that good? You guys all hearing this? Because my computer should not be your problem. Right? You guys, if you're doing the calculations right, it should not be a problem. Okay? And today we'll talk a little bit more about how numbers actually have precision from the lab. Because a lot of students don't understand that, and that actually is relevant to you. That when you watch a gas flow meter or you do a shot, depending on which syringe you use, you could have a plus or minus much different. You understand what I'm saying? Like if I grab a big syringe and I'm trying to add a microliter, I'm probably not going to work. And I'll help you guys with that concept. Very, very straightforward. All right, how you doing on this? You think you can roll through this if you want? I've got one more set if you want to just take another spin where you guys do it. Want to do that? Yeah. Now again, I'll probably just allow you to just do this on your own and then try and do all these. We'll let you work with your partners, ask. And when you get done, make sure you guys agree. So you're like, okay, here's what I got, here's what I got. And everybody's like, and then talk to each other to me if you're not getting one of those. And I'll try and help you. What is that one? I don't know where that's coming from. That's this one right here. Oh, I see. You're making the full jump.
Or should I just stick to
I'm just checking right now. I actually don't know if I have to think about this for a second. I don't know if that's correct.
Okay.
Now here's what I'm going to tell you. I'm not going to give that to you.
Yeah.
I'll give you the ones that so I would probably get used to using mine because that's what will be given to you.
Okay.
Yeah, later in the semester you'll have the ability to write your own half sheet.
Oh, so that's.
But right now I'm not doing that yet. So I'd probably stick with mine. I better pause this. Take a minute, get these. See if you agree with me. You agree? Make sure you sign in. we do it? Are you guys matching these? Yes, no? Anybody need one of them done for you? Any of these done that you want me to do for you? You okay? Okay, good. Okay. So there's temperature conversion, but the bulk of what you do in chemistry is metric conversion. You just got to always kind of, what I really try and encourage students, and this is across the board, physics, chemistry, engineering, medical type, real in-depth applications. Some of you guys did this for a while and you're like, you know what, I want to be in dental school, and you come back and do more technical stuff. Temperature should always throw up a red flag and just stop for a minute. Be careful when you're around temperature conversions, because they're the ones that'll get you every time. So if I'm hanging out in chemistry too, I'll be talking about some formulas that I'll point out to them that are like, you got to convert temperature beforehand before you do this. But the thing about it, just if I was to generalize, I'd say, if I'm doing calculations in chemistry, I usually run to Kelvin and I will be safe. That's generally true. So I think that's it for this. Good stuff.